Hello students, this is Niteen Mohod, and through this video we are going to learn arithmetic and logical instructions in 8051 microcontroller. This is part 1 because there are a number of instructions. We have divided it in two parts. So moving on to the first instruction, that is add a comma source byte. The meaning of this instruction is the source byte will be added to the contents of accumulator and the result will be stored in accumulator. Here what is required, since A is 8-bit size or a byte size, source byte has to be a byte size, means the size of this accumulator and the size of the source byte should match, in short. Now unsigned addition. So in unsigned addition, how it is performed, that we are shown here. So first instruction is move a hash 33h. The meaning is move 33h data into accumulator. We are calling this 33 as a data because hash sign is there before the data. Similarly, second instruction is add a hash 3bh. So this instruction adds data 3bh with the contents of accumulator, and the contents of accumulator you can come to know from the first instruction that they are 33. So 33h plus 3bh, as a 8-bit number they can be shown like this. So on addition of these two 8-bit numbers, we will get this as a resultant 8-bit, you can say, and this resultant 8-bit can be written as 6EH in hexadecimal. So 6EH will be the final contents of the accumulator after the execution of these two instructions. Now when we are performing this addition, there is no carry generated at D3 bit position, and therefore there is auxiliary carry which is 0 shown. Similarly, no carry is generated which is generated at the D7 bit position, so carry bit is also shown 0. Moving on to another example, move a comma hash 0FEH. So this will move FEH data into accumulator. Here 0 stands for that FE is a hexadecimal digit, and hash shows that the number which is following it is a data. So FE is a hexadecimal number which is moved to accumulator through this instruction. FE is written like this in a 8-bit. Then move R3 hash 75H. So here data 75H will be moved to R3. So first data moved to accumulator, second data moved to R3. The third instruction is add a R3. So it will add the contents of register R3 with the contents of accumulator, and the result will be stored in accumulator. So here you will get this result, which is 01110011, that is 73H, and this is the carry bit actually which we have taken down. Now here during this addition you can clearly observe that at D3 position the carry is generated and it is moved to the next position, therefore auxiliary carry is equal to 1. Similarly, at D7 position the carry is generated and 1 we are getting as a carry, therefore carry is also shown 1. So this was another example. Now we are going to see the addressing modes which are supporting add instructions. Means there are different add instructions we are going to study under this, which are supporting different addressing modes. So first is immediate addressing mode, and the addition instruction is written in this particular mode like this: add a comma hash data. Now hash means the number which is following that hash sign is a data. So as an example we can say add a hash data hash 25H here as a data. So it means 25H will be directly moved or be directly added to the contents of accumulator, and the result will be stored in accumulator, or sum will be stored in accumulator. Then the add instruction which is supporting register addressing mode. Here the syntax is like this: add a comma Rn. So here Rn can be any value from R0 to R7. So example can be written like this: add a comma R3. So here the contents of register R3 will be added to the contents of accumulator, and the sum of them will be stored in accumulator. Direct addressing mode supporting add instruction. So add instruction will be written like this for this particular addressing mode: add a comma direct. Example you can write add a comma 30H. Here since there is no hash sign here, So 30H will be the ROM memory location. So the data contents of this location whose address is 30H, those contents will be added to the contents of accumulator and the result will be stored in accumulator. Then register indirect addressing mode supporting add instruction is now add a comma at the rate ri. So here there is no hash, there is a at the rate sign. Example, you can write like this: add a comma at the rate r0 or add a comma at the rate r1. It adds the data pointed by r0 or r1 to accumulator. Means what is happening here? Here the contents of ri means content of r0 here or r1 here, that is actually the memory location, and the contents of that memory location will be added with the contents of accumulator and the result will be stored in accumulator. This is what the meaning is. Then sign addition and negative numbers. So here overflow flag sets when the result of sign number operation is too large, resulting high order bit to overflow into the sign bit. We will see that. Now one thing is very clear here, that overflow flag or carry flag bit is used to find the error in signed or unsigned arithmetic operation. It means overflow flag bit is used to find error in signed arithmetic operation, while carry bit is used to find error in unsigned arithmetic operation. Now as an example of this sign addition and negative numbers, we are going to see these instructions. So here move a hash plus 8d, d stands for decimal. So this 8 is a decimal number which is represented like this. So in 8-bit it will be represented like 00001000. Why 8-bit? Because accumulator can accommodate 8 bits. So that's why we have to write plus 8d, that is decimal, into 8-bit. So this 8-bit data will be moved to accumulator. Then move R1 hash plus 4d. Now 4 means 0100, but in 8-bit you will have to write it like this. So this data will be moved to R1. The next instruction is add a R1. So here the contents of register R1, that is these contents, will be added to the contents of accumulator and the result of this sum will be stored in accumulator. So you will get the result like this: 00001100, which is the addition of these two 8-bit numbers, and this is nothing but plus 12 decimal. Here in this case overflow flag is 0 and carry flag is 0, so no carry is generated and the result is not going beyond the limit. That's why overflow flag is also not set here. Second is instruction is, or example, move a hash minus 12d. Now minus 12d, how to write minus 12d? So minus 12d is basically the 2's complement of 12d. Now how 2's complement of 12d is obtained? So 2's complement of 12d will be equal to 1's complement of 12d plus 1. Now which is written as this 11110100. So this is if you obtain the value of 1's complement of 12d and add 1 to it, you will get this value, and this value is treated as a minus 12d. Hence now we will see the further instructions. Move R3 hash plus 18d. So here 18d, decimal number 18, means which is written in binary like this, and additional zeros are added here. So this 8-bit number is representing plus 18. So plus 18 will be moved to R3. So minus 12 moved to accumulator and plus 18 moved to register R3, and both these are the decimal numbers. Now when we perform the third instruction, that is add a R3, so what will happen here? It will add the contents of R3 with the contents of accumulator and the result will be stored in accumulator. So hence after addition of add a comma R3, we get the two numbers 11110100, right, plus this number, right. So we have added these two numbers. One is 2's complement of 12d and second is this contents of R3. This we have added. So we are getting this number in blue color we have shown. This is the addition and this one as a carry. So since the result is going beyond the limit, therefore auxiliary carry flag is set. Similarly, carry is generated, therefore carry flag is 1. So this is how the signed additions are performed. The next instruction is ADDC A, source byte, and the meaning is add with carry. This stands for carry, so add with carry. So what is the meaning of this? This adds the source byte to the contents of accumulator along with the carry bit and place the result in A. We will see it through example, it will be clear. If carry equals to 1 prior to this instruction, means before this instruction, if the carry is equal to 1, then 1 is added as a carry bit, otherwise 0 is added. So now moving on to the instruction. Here we are clearing the carry. So carry is clear by the instruction CLRC, carry is made 0, and move A #ATH. So data ATH is moved to accumulator. The instruction then is ADDC, this is add with carry A, 92H. So it will add 92H with the contents of accumulator, that is ATH, with carry, and carry was 0. So 80H plus 92H plus 0, that gives 12H plus carry equals to 1. So this is what you can get clear from this example. So ATH when added to 92H, we are getting 12H and with 1 carry. Now carry is equal to 1, we are moving further within the same program. So move R3A, so the contents of accumulator, now contents of accumulator are 12H, which is the result, that 12H will be brought into R3. Then move A #15H, so 15H data will be brought into accumulator. And the next instruction is ADDC A, R3, so it will add the contents of accumulator, that is 15H, with the contents of R3, that is 12H. So 12H plus 15H plus the carry will be added. Now carry in the previous step was 1, so 1 will be added, and when the addition will be performed, you are getting this addition as 28H. So you are getting result as 28H. Then we are moving on to SUBB A, source byte. This is subtract with borrow. Subtracts, it actually subtracts the source byte, means this byte, and the carry flag bit from the accumulator and stores the result in accumulator. Here the internal hardware of CPU performs the following steps. You just keep it in mind that what internal CPU does, it takes 2's complement of the source byte, this one, then adds it to register A and inverts the carry. So we will do it through example, but before that you have to keep in mind these 3 conditions, that if the destination is greater than source, then carry will be, or carry bit will be 0 and the result will be positive. If destination is equal to source, means the data at destination is equal to the data at source, then carry will not be generated, carry bit will be 0 and the result will also be 0. And if the destination byte or the data at destination is less than the data at source, then the carry will be generated and the result will be negative in 2's complement. Example of SUBB A, source byte instruction, that is subtract with borrow A, source byte. So here move A #45H, so 45H will be brought into A. Then clear carry, so carry by default, if it is 1, it will be made 0, CY equals to 0. And the next instruction is subtract with borrow A, #23H. So here this 23H will be 23H along with this carry bit will be subtracted from the data which is held by accumulator. So 45H minus 23H minus 0, which is a carry bit. So when they are subtracted, we are getting 22H. Here we have shown it in numbers. 45H can be written like this in 8-bit. 23H in 8-bit written like this. Actually, this is what 23H, 2's complement of 23H, Why 2's complement of 23H? Because we, instead of writing, when we are writing negative number, we are writing the number in its 2's complement form. So that's why here 23H is written in 2's complement form, and it is like this. So 23H original number is like this, 0010, that is 2, and this is 3, 23. So its 2's complement can be obtained by taking its first 1's complement. So 1's complement is taken first, means all zeros are converted to 1 and 1's to zeros. So when 0 is converted to 1, you will get 0, 1, 1. This 1 will be converted to 0. This 0 will be converted to 1. Similarly here, this 0, 0 will be converted to 1, 1, and 1, 1 will be converted to 0, 0. So 1's complement we have obtained for the 23H. Now this 1's complement plus 1 gives me the 2's complement. So 2's complement will be this 1's complement plus 1, that is the 2's complement, and this is that number. So after this, when we will add them, we will get this result, and carry bit will be equal to 1. Note one thing here, that there is no subtract instruction in 8051. Hence, to perform subtraction, make carry equal to 0, which we have done here also, and then use above instruction, that is subtract with borrow. Means subtract with borrow instruction will work as a subtract instruction in 8051, provided you will have to initially make some adjustment, that is carry equal to 0. Then moving on to increment, decrement, and DPTR instructions. So increment byte and decrement byte, these are the syntaxes for increment and decrement instruction. We will see first increment byte. What it does, it add 1 to register or memory location. For example, INC A means increment A, means increment the contents of A by 1. Example we can take as INC 30H. Now 30H, since it is not preceded by hash sign, this 30 will be a memory location. So the contents of memory location whose address is 30H will be incremented by 1. This is actually the RAM location. Similarly, DEC byte, here what it does, it subtracts 1 from the specified byte operand. Means given byte, whatever it may be, it will be reduced or it will be decremented by 1. As an example, the instruction is DEC A, so it will decrement the contents of accumulator by 1. Another example, DEC R1, so it will decrement the contents of register R1 by 1. Then INC DPTR, this is increment the 16-bit register DPTR, that is data pointer register, by 1. Only this 16-bit register can be incremented in 8051 microcontroller. As an example, we will take here move DPTR hash 16FFH. Hash tells us that 16FF is the data, 16-bit data, which will be moved into DPTR. INC DPTR, so it will increment the contents of DPTR by 1. And we will get the result 1700H. How? See, 16FF, so we have written here 1 hexadecimal as 0001, then 6 as 0110, then F as all ones and F as all ones. And when this is incremented, means this is increased by 1, so we'll have to add 1 here, 0001, and the result which we will get will be 1700H. So this is how this instruction is performed. Note one thing here, that DEC DPTR does not exist, means decrement DPTR does not exist. So I hope the idea about the arithmetic and logical instructions, which we have covered here in part 1 video, given with the examples, are clear to you. Thank you.